All right, so high-level axiomatic statement. We presume reality is made of information, and the information itself lives within a substrate of thought. In fact, the information is thought. Just like a thought that you have in your unexplainable consciousness is both information and thought at the same time. But the thought is emergent from the information, which is emergent from the thought, which is emergent from the information in a strange loop. So it's like you think of a thought, and then the thought itself changes you, and then you think again of a similar thought, and then it changes you again. So thought is information is thought, and the universe thinks itself into existence, as explained in the self-simulation hypothesis paper that we published. So we have this idea of a thinker. It is a thinker of a unit of information. That unit of information has multiple equivalencies, some being geometric, some being numerical. And then the thinker also thinks a different thought, which is the thought of a simple program. So in some sense, the simple program is operating upon the first thought, which is the geometric object with its units of geometry that composite to make a bigger geometric object. So the thinker thinks a thought of a simple program that generates new thoughts called relationships between the units of the first information that we talked about as a unit of information, where eventually complexity emerges in the thought of running the simple program until the complexity itself becomes the thinker. So that's the self-actualized strange loop that is the underlying physical or reality-based ontology of what reality is. Code and language are synonymous terms, at least the way I use them. We define a code or a language as a finite set of object types with relational rules and syntactical freedom within those rules. And we recognize that all information is expressed through codes or languages, C++, DNA protein folding algorithms, poetry, bird song languages, bit-to-byte expressions, and so on. So since information equals thought, then thought itself emerges within the thought of language, right? It's an ontology where everything is thought, but everything informational, including thought, which is informational, is in a language or a network of languages. Simple programs must be coded in a language. The thought, which is reality, is a simple program being run on simpler thoughts of math related to E8 and a Fibonacci code substrate. But the thought of the simple program is high EC. Now examples, so emergent consciousness. So examples of EC include spirituality, politics, mathematics, physics theories, irony, and the thoughts behind a multiplayer virtual reality video game. The simple program itself does not live in geometry or number. It transcends that, as any high EC thought does. So just as our ideas of spirituality, irony, and so on transcend the mathematical aspects of our biology or our physicality, the simple program is a thought like that. For example, So for example, C++ is not the origin or the substrate of some video game that was programmed in C++, obviously, right? The video game is strategically chosen by the consciousness of the coder. So the code, the simple program, is not the code. The fundamental language that we work with is the Fibonacci matching rules. Now, from that, we get emergent analogs of the Fibonacci matching rules, such as the Penrose tiling matching rules and matching rules in an object like the Elser and Sloan quasicrystal or the CQC. The fundamental code is not physical, it is pre-physical. It's just some pre-physical math. Physics emerges from a simple program that has been strategically chosen to order networks of legal expressions of the code, legal expressions of the Fibonacci, of the fundamental underlying Fibonacci matching rules. So code does not equal simple program. We axiomatically decide that the basis of the code is derived from the root lattice of the largest exceptional Lie group. And we have some rationale and reasonable thinking. It's not just an axiom on just whimsy, but it's still an axiomatic decision to think that the code is based on the largest exceptional Lie group. So the E8 root lattice is not a code, and that's why I use the word in the above paragraph, derived. But we can turn it into a code, right? It becomes a legal expression of a code when some part of it is irrationally projected, some sufficiently large part of it is irrationally projected to any lower dimension greater than 0. The selection of a part to be projected is the selection of some syntactically legal expression that the particular quasicrystal tiling code would have, right? So there's an infinity of irrational angles, and they all create slightly different codes. It's like if you project the points on the Z2 lattice to one dimension, there are an infinity of angles that give you a 2-letter code. And then there's a second infinity that gives you a 3-letter code and so on, right? An infinity of 4-letter codes and so on. So the value of the irrational angle determines the particular code. Because of their algebraic qualities, we are interested in the HN class of codes, the codes based on 5-fold axes of symmetry that lead to Dirichlet integers. And we have lots of suspicions and we have lots of factual justifications on why we're interested in these H symmetry codes. We've got algebraic understandings, we've got neat matrix diagonalization understandings, we've got a lot of appreciation for Dirichlet integers. So again, changes of the coordinate of the boundary that projects the points to some lower dimension will define a new legal expression of that code. So the code is sort of set by the hyperangle, if you will, if it's irrational, and then the movement of the boundary at that angle relative to the root lattice is what defines updates on the graph, where each update is a legal tiling of the quasicrystal space, and where you can see each update, if you like, as an inflation, which leads to a legal instance of the code. So an instance of physical reality is some sufficiently large ordered set of shift vector actions up in E8, right? These are inflation values of a base point set at phi 0. That is the fig without edges, right? So we construct the fig as a series of planes, and then we get these edges and points that emerge. But if we delete the edges, we've just got a point set. And so I'm speaking of the simple case where we have the same possibility space in these slides so far, right? It gets more sophisticated as you change your possibility space for each element in the ordered set, right? So I'm just speaking simply about an example with a fixed possibility space. So anyway, an instance of the quasi-crystal or a single inflation is not physical in this paradigm. Physicality results from the chosen simple program that defines the ordering of a sufficiently large set of individual code legal tiling arrangements. Now, given some initial condition, this simple program would generate a deterministic index of ordered sets of these, tilings or graph states as inflations. So if you had the same initial condition and you run the simple program, it should generate the same ordered set, or if it's a simple program that gives you a weighted set of ordered sets, it would be the same way every time if the initial conditions are the same.
Depend on the rule that you use.
Yeah.
If it's a non-deterministic rule, it will be not the same.
That's what I'm saying. You can have one type of simple program that generates one and only one ordered set given some initial condition for that simple program. Or you can have a different simple program that gives you a very large set of ordered sets where there's different weights on those sets.
I just say that you will need some rule to generate the weights. But if it's a deterministic rule, it's one thing. It's a non-deterministic rule.
Well, I'm saying that with the large weights, I'll get into it, but for me, this is a story where I'm trying to tie in the weight to the probability of an emergent animal measuring some aspect of the pattern. And so when they put their consciousness in and try to measure it, something weird happens, right? Where the system is apparently interactive with the conscious measuring entity, and it modifies the future portions of the order going forward in the experiential time of the measurer. It changes it. But if there is no measurement, both classes of programs for me, whether there's a program that gives you one and only one ordered set, or whether there's a different kind of set of rules that gives you 10 ordered sets, each with different weights. What I'm saying is that I would expect, I would predict that the simple program that gives you the 10, it will always give you the same weights on the 10 each and every time if you were to start it at the exact same initial conditions with the same rules. So it's consciousness that comes in and makes things weird and non-deterministic, because although we cannot define consciousness scientifically, people have tried. There's just no good consensus, not at the conferences that I've been to. But we can speculate that consciousness makes choices that are not strictly determined by the environment. We can speculate that. We can say, oh, I'm compelled to do this and that. I'm a high level consciousness. I'm super compelled. This is what I should do, but I'm going to do exactly the opposite of what I should do, even though I usually do what I should do. So this idea of free will, okay, whatever it is, I can no more define free will than I can define consciousness. And these conferences that I have gone to 3 times, there were Penrose comes, a lot of high-end quantum physicists, neuroscientists. It's not a new age conference. It's a real academic conference at the University of Arizona. And one humbling thing about that conference is that everybody agrees we don't have any consensus definition of what the heck this word means, consciousness. We're nibbling around the edges as scientists, and we are able to kind of agree on a few things that consciousness does, but we can't define it, right? And then you have this other thing called the hard problem of consciousness, which is, okay, we can't define this substance called consciousness. We can't get a consensus. And now we want to talk about how this substance emerges from substances which are supposedly not conscious. And so it's a big mess.
Just say that at the level of the simple program, you can build with a deterministic or non-deterministic rule.
You can.
It seems that you are saying that you are interested in the determinism case.
No, I don't think he is.
Not necessarily. What I'm saying, the idea of what is or is not, in other words, what physically occurs or does not occur, this is a philosophical concept. And what I'm saying is that until a consciousness like you starts swimming through the gigantic indices of sets of ordered sets, nothing has really happened physically necessarily.
It's all like a probability.
It gets actualized in your mind, and even then it never collapses down to some specific ordered set, because
the level of the program, like a C moving from one position to other, it can have a deterministic or non-deterministic rule to the side.
it can, but what I'm talking about is the indices. Before I'm talking about anything moving or anything like that, I'm just saying in one case, I can make a simple program that gives me a single weight set on one ordered set. It just gives me one. And if I were to do it again, it would give me that same, it could give me that same one. Or I could make a simple program for the one that I hook up to a random number generator, right? Like you're saying. And I could say, okay, even when it gives me one, I can hook it up to, I can make a couple steps in an algorithm. I can modify the algorithm by the insertion of a hinge variable that I wire up to a pseudo random number generator or a real random number generator. And in that case, the algorithm now is not a normal algorithm. It's an algorithm that requires a random input, right? Before you get an output. So anyway, I think I'm agreeing with you on that. There's a lot of different clever kind of ways that we can insert hinge variables, randomness to get non-determinism. But for right now, I'm trying to just stay simple, and I'm suggesting to you guys that in our work, we will have an algorithm that is a simple program, and that orders these large quantities of sets. I'll use 10 sets, and there'll be these different weights. Now, what will be interesting is when you get the same weight on two or more members of the set, right? So I've got 10, and number 6 and number 8 have the same weight. So then if I were going to look at that index, I'd have to say, well, there's an equal probability of these two things because I'm associating my weights with probability, but none of it is real. It's very abstract. Okay, then I get some animal like you that emerges in this simple program, and then I can ask, well, what's the probability of Marcelo measuring something that correlates to number 6 or number 8, right? That's some span of order for a random walk. And then that is how I would interpret that, is I would say, well, there is a 50-50 probability between those two things of him measuring that, if it were only those two things, those two random walks. All right, so if one were to use a random number generator to select from a choice of two ordered and weighted sets, then the probability of selecting the set with a weight of 10 would be twice as likely as randomly selecting the set with a weight of 5. So we have a mapping between the 10 convex hulls of 24 cells of the 8-dimensional 24-cell 10 compound and the 10 foregroups of the 4-group 10 compound, aka the right plus left 20 group. So 24 cells do not project to 4 groups. They project to cube octahedra with some other points on the square facets. The simple program works in tenths, or you could make one that works in fifths. For example, if we had a 20 group, well, that would be an object, right? That's not a quasi-particle. That's just a piece of geometry. But if we created a sequential cycling of 4 groups on that 20 group, then we would have a quasi-particle. The simple program that I have in mind is based on the PEL, Principle of Efficient Language, via some, I don't know what it is, but some to be discussed and to be discovered notion of efficiency that plays off something like hit density deltas. So I want to remain loose and agnostic, other than my general feeling that there's some idea of efficiency going on, and there's something that plays off of the hit density deltas. So there are a few options for this, such as a new thought that Fong shared with me on Friday. Remember? So I'm open-minded. The games that we need to program generate indices of ordered sets with weights. The probability of different ordered sets is equal to the probability of each of the ordered sets is equal to the probability of some quasi-particle interaction being expressed in that animation. And a simple program is strategically chosen to weight probabilities according to hit density flow patterns, bold green, made of hit density deltas, bold red. So note the difference between a flow pattern in a hit density animation and the deltas in density. Any flow pattern that's made out of hit density is a coherent or hit density deltas, right? So you have all these gradations of hit density, and that doesn't mean it's a flow pattern. So any flow pattern that is made of hit density is a coherent or not totally noisy pattern of hit density differentials that has something about it that reminds you colloquially of flow, cigarette smoke, fluid, right? Waveform principles like interference. So if all volumes over n frame had the same hit density, right? All minute volumes over n frames and some bigger volume, if they all had the same hit density, well, of course, you could have no flow patterns of hit density, but you also couldn't have any other patterns of hit density that are not specifically fluidic hit density patterns. So what I've got in mind is fluidic-like delta patterns made of deltas in hit density as my primitive notion of the energy landscape in some game. However, orderly patterns of hit density deltas do not need to be flow patterns. By flow, I refer to a colloquial notion of fluidics, waveform, and interference. Something that cycles between states is not yet a wave-like or fluid thing for me. But when you cycle it and translate it at the same time, then to me, waveform emerges. So for example, I can move my hand up and down, and I can call that an oscillator, right? And I'm moving it up and down. But if I were to move it up and down just like that, periodically, right? And then walk at a constant motion, then I would trace out a sine wave. So it's this combination of 3D and 2D rotations, rotations relative to a circle on the helix and rotations in fifths on the two-sphere. And when you combine those with a constantly changing position, the interpolation of that type of animation in the extended structure, right? All the empire framework, okay? All of that is going to have to encode the behavior of this local cycle clock going through its fifths on a two-sphere and then circling in its fifths or tenths on a helix, and then translating like as on a zero sphere along the axis of that helix. So I can cycle my clock on the 20 group in place, but when I translate it along a straight line while cycling, I get an interpolation between the sum of the 1D translations and that 3D cycle clock in fifths. But I can do a more complicated interpolation by translating it along a helical path in discrete steps. Now I have to arbitrarily pick right or left helicity. So I'll pick left. Now we have an interpolation of a cycle on a 2-sphere where I picked left, and a 1-sphere, I'm sorry, a 2-sphere where I picked a directionality. Because remember, you have to pick a directionality in your cycling of fifths. You have to pick an axis, first of all. So if you were to want to see a coherent pattern of cycling on something like this 20 group, you'd have to orient yourself on one of the axes. So here, if we want to cycle on, if we colored each of our 5 4 groups some color, like shown here, then if we decide to pick one of the 6 axes, then we can create a pattern like on a wall clock, where it goes right or left around a circle. But if we were to be looking at that same pattern cycling from one of the other of the remaining 5 axes, we may not be able to pick up any order. So you pick an axis, but then once you've picked an axis to have an orderly cycling of 4 groups, you can reverse that order. It can go in the opposite direction on that axis. Now notice that's not helicity. That directionality of the cycling of the 4 groups is a completely different binary value. So you have a six value. You have to pick one of 6, which is the axis. Then you have a binary choice, which is which direction on that axis. And if that is encoded into the infinite discrete field, if we are working with an infinite quasicrystal or a universal sized quasicrystal that's very big, then those values, the one of 6 you pick and the directionality, the binary value, as well as the helical value of right or left, all of those values are imprinted or encoded into the extended structure of this field that I usually call the empire wave field. So those are examples of what we have decided to call the intrinsic state variables of this little cycle clock game particle. Maybe turn. Okay, so let's go on. So that's this term empire wave, which I've always meant to be something that only exists over sufficiently large frames. It is extended in the 3+1 space of the QSN. It goes out all the way to the end. And it may fade in density with distance, maybe. So as you imagine all of those intrinsic state variables being encoded in the local empire structure that extends around the cycle clock, perhaps it drops with distance in terms of the global encoding, or perhaps it doesn't, but that's the empire wave. So nothing in our program is physically real unless it occurs over the emergence of this interpolation concept over sufficiently large frames. The SO cross S1 cross S2 interpolation, known as the empire wave, is one of the most beautiful things I have ever seen. And I know that some of you have told me that you cannot see it, and some of you have said that you're not even sure it is there. And that's my leadership role. I see something, it's visual, it's intuitive, it's been thought about a lot, and I have lots of logical reasons why I can argue it is there mathematically. but we haven't really done much calculating of an empire wave, just as nobody has calculated a weighted set of two or more sets where there are different weights. So there's a lot of things that I want to push through the membrane of kind of slowness on and bust through, whether it's kind of getting some of you guys to click and get more on this, or getting other people that we hire. But this is what we need to do. So I'm claiming the SO cross S1 cross S2 empire wave is defined by a simple program. It is the simple program that generates that, and it's arbitrarily chosen. It's not arbitrarily chosen, it's strategically chosen by the universe according to the PEL. But the fact that the universe would choose the PEL, that too is a choice that it didn't have to make. Like, why does it have to be efficient? You know, so I'm claiming it is wave-like, and its pattern reaches out to the end of the simulation, encoding whatever the intrinsic state variables are in that cycle clock. It contains a set of these intrinsic state variables that are encoded into the discrete empire wave field around it. And two or more empire waves from cycle clocks create a collective discrete field with objects in it that are called relational state variables. The collective discrete field is the energy landscape in the game, in this story. And it has a contribution in it from all cycle clocks. So in any volume, any meaningfully microscopic value, right, greater than a Planck volume in this game philosophy that I have, contains a contribution of the cycle clock intrinsic state variables and the global relational state variables of every single other fundamental quasi-particle that is operating in this simulation philosophy of physics. So the field is probabilistic, and it's not what you'd think of as physical, because each possible energy landscape has a weight of probability according to the simple program that considers a savings notion relative to the hit density patterns. Let me put that differently. I've described to you this fluidic space of deltas of hit density creating flow patterns, right? The flow patterns are ultimately driven by the evolution of the quasi-particles, which start off with these rotation with pi. They start off with pi in mind, right? And then they behave relative to one another as they flow in or repel away from different hit density values, which are made of intrinsic state variable encodings. And their collective behavior, when you get enough of them, is fluidic. In other words, the particles themselves become fluidic because the energy landscape is fluidic. But it's not as though I'm claiming that there is some physical energy landscape. It is this vast index of weighted ordered sets where every single different ordered set in the index, like imagine an index with 10 to the 400 different ordered sets. Within that, you have some that are, they have different weights, okay? And so that's very abstract. I would not want to call that physical. I'd say that's physics. It could be it's my game physics right now, it's toy. And later that idea could be a physics model, but the ontology at that point in the physics model should claim that it's still not physical, a la a sort of Bohr-esque viewpoint where the probability space is not quite physical. It becomes physical upon, concatenations of measurement. Then you can say, okay, I've got this little physical ontologically physical thing over some duration for this system I've been observing.
Pilot wave.
Yeah, it's like it is similar to the idea of a pilot wave in a way, because we've got this idea that this fluidic wave-like thing, and the pilot wave is giving non-deterministic, probabilities. It's like a non-deterministic energy landscape that governs the random walk probabilities of the evolving systems.
So as opposed to probabilistic passes, you're giving a probabilistic field.
Yeah,
Then,
right.
Because when you actually take a pass, that becomes a pass. But
Right.
if you don't, then it's kind of more field.
Right. So think of relational state variables as the energy, okay? And think of the intrinsic state variables as the quantum states of the particles in my game. So whatever their relationships are in that set of intrinsic state variables, which we did that big whiteboard color illustration at one point a year and a half ago. And on there, we gave explicit examples of what relational state variables are and what intrinsic state variables are. And all of that is still ready for prime time. Like I wouldn't change anything about how I define the intrinsic and relational state variables. But if you can't recite them off the top of your head, then that's what I'm asking you to do, because this is the agenda that I want to put resources behind and get and move into this way of thinking. So the thing that you call physical is your consciousness swimming through this enormous set of weighted sets and modulating the weights on those sets via your observations, which all occur in your consciousness. So here is a conundrum. We have a state of humanity in our current level of philosophy, neuroscience, physics, where there is no consensus on what consciousness is. And yet we are building a foundational axiomatic, kind of program here, where we say that this stuff that we cannot define what it is somehow, whatever it is, going into these vast indices and that are made of consciousness, that are inside of a thought of some collective substrate and interacting with it, right? Modulating the weights. And it has to modulate the weights both forward and backwards, because the very ontology here is that there is nothing that exists in a frozen state. The particles, the space, the time, all of the things that would be simulated and be called physical in this ontology only exist in sufficiently large ordered sets. And so you can see how that means, well, wait a minute, if I am changing the indices, do I only change it going forward, or do I change it also going backwards? Well, it depends. If you did some measurements in the past, like 5 minutes ago, and if that got into your high EC consciousness, which is interactive with this collective substrate, then the collective substrate will make a deal with you and say, cool, you remember that result from the past. I'm not going to change the values, the weights on the indices for those, because you actualized that with your consciousness. So 2 or more empire waves interpolate to create a generalized notion of interference. I'm calling it colloquial interference and colloquial waveform because Richard coached me yesterday to say it that way so that I don't trigger any of you to remember classes that you took on waveform, interference, or anything mathematical or physical. Just my safe zone is to say colloquial. I see these things as looking to me like interference, looking like waveform, looking like rotations. That's what I see. So accordingly, with these two or more empire waves interpolating together to create a kind of interference concept that defines their mutual shared energy landscape. That probabilistic energy landscape is itself mathematically, to me, made of a discrete notion of something that looks like interference, the way I colloquially understand some of it. So let's leave geometry now. The elements of each ordered set are a set of Dirichlet integer coordinates. In other words, each element is a legal quasi-crystal with a global quasi-crystal center emperor in it. A flat quasi-crystal has only one CE, but non-flat quasi-crystals can have more than one CE. Don't worry too much about that, maybe right now. And each of these elements group together in ordered sets, which get weights. So the energy landscape of probabilities discussed can be seen numerically as a gigantic index of these Dirichlet integer coordinates. So each Dirichlet coordinate in 3D has a second life as an integral octonionic coordinate in 8 dimensions. So with quantum mechanics, we have the idea that a probability is derived from a probability amplitude in a formalism based on the complex plane. Now, it's possible that the index weights that I imagine and speak about might be able to map to probability amplitudes in some higher dimensional number system, such as complex numbers, maybe. But why? Why would they? Why would they map to complex numbers? And by the way, what's up with the interference in quantum mechanics, right? Why would two probabilities interfere with each other? So the first part of that question, so think about the fact that the points of the D4 root lattice are a set of quaternionic integer coordinates, right? So all you've got is the D4 lattice, right? The kissing points of the maximum packing of 3 spheres in flat R4. No edges, just a bunch of points. And if you turn those points into coordinate system, obviously it would be an integer coordinate system because it's just those points. And so anyway, because it's a 4-dimensional system, we can all see how we have the D4 root lattice point set is describing a quaternionic number coordinate system in R4. And then the points of the E8 root lattice are octonionic integer coordinates made of planes of complex integer coordinates. But it's also made of quaternionic planes, right? So we can decompose the E8 point set as integral octonions. We can decompose it as integral quaternions or as integral reals or complex numbers. But I'm going to focus on complex numbers just because I'm trying to answer that question back here at the bottom of this slide, which is why would it relate? Why would the probabilities in my index somehow ever be able to relate to probability amplitudes that have anything to do with complex numbers? So we transform or crush the integer values on the complex planes in 8D into Dirichlet integer values in the CQC. So you can place a magnitude, for example, of square root 2 as your unit root vectors in 8 dimensions. And then as we crush that down, that 8-dimensional rep down into a lower dimension, like the CQC, using our 5 or 10 camera orbit positions to sequentially build it up, then what we've done is we've converted square root 2 magnitude unit roots in 8 dimensions. We've compressed them down to a set of more than 2 Dirichlet coordinates in 3D. depending on what the angle of that E8 root vector was relative to either the structure of your projection window boundary or your projection boundary, or relative to your projective 3 space, R3. So anyway, when you think of the numerical essence of the units of curvature equivalency that we use, so these are all equivalent to curvature, and they turn into a language or a code of letters made of curvature equivalency. But when you think about the numerical essence of it, you have to think about how you're transforming these numbers like octonions, quaternions, and complex numbers, right, that live in the pre-transformed states. And you're transforming them and the reals, and you're transforming all those 4 classes of numbers into these Dirichlet values, where the different values are different magnitudes of curvature equivalency. So I'm not surprised that quantum mechanics relates to higher dimensional numbers, because I believe that reality has a lot to do with this basic idea that we are trying to assemble here at QGR. And I am also not surprised that the probabilities interfere with one another in quantum mechanics, because they most definitely interfere with one another in the relational state variables that I am struggling to define for you guys, right? There's still a delta between what I have as an inner knowing and a bunch of logical things plus an inner intuition, and being able, and I have a lot of visual, I have a lot of inner structure knowing for me. So I don't claim that you should have that, but for me, I see these probabilities interfering with one another. So now we're going to talk about the 2+1 dimensional shell model. So the foundational substance of our model, as I've said, is thought. A human has a consciousness that is large enough to run a simple geometric program like tic-tac-toe. You can hold it in your mind as, you know, as your mind acting as the consciousness-based substrate. I can ask Richard, because he's smart, I can say, Richard, hold a 9 square 3x3 grid in your mind. And if his mind is quiet enough, he can hold it. And then I could say, you know, all right, I'm going first, I'm placing an O on the upper left. And now you place it there in your consciousness. And he can run the whole algorithm of tic-tac-toe with me in his consciousness. And it's geometric. Both the grid is geometric, the symbols O and X are geometric symbols, and then this rule set that we agree on for tic-tac-toe, that's not so geometric, that's a little bit more abstract and arbitrary. But he can do that, right? And so a genius, like Ray, thank you, you're a genius. So Ray might be able to run in his consciousness a very small number of iterations of some 2D cellular automaton in his big consciousness. An emergent future consciousness that is godlike compared to us could in principle run my imagined simple program over exceedingly large iterations, such that in principle it could simulate itself.
A good chess player can play chess in their consciousness.
Yeah. Okay, so just as letters are the abstract fundamental thought in the code of this presentation, the fundamental thought in our simple program-based physical reality are the E8 lattice root vectors, right? Like, in other words, you can't see the pixels of our monitor. So for you, the irreducible kind of code theoretic object that you can pick up on is the individual letters, right? And so the letters in my idea of codes upon which run simple programs, those simple code letters for me are E8 root vectors. So these root vectors exist in certain packages of 6, which form 3 simplices in 8 dimensions. As those packages of 6 are transformed to 3D using the camera orbit scheme for compounding sequential fifths and tenths of cycle clocks, those square root 2 length roots get compressed down to a value of 1. And the compression magnitude is equivalent to some magnitude of curvature, which is equal to the angular relationship between the root vector and the projection space, or between the root vector and the projection boundary in 8D that captures some quantity of these unit root vectors. Now, when those edges contract, they're emergent objects, such as their volumes, right? So the volume, if I contract all my edges, obviously by definition, I'm going to be contracting the volume described by those edges. In this case, I'm contracting all 6 by a factor of 1 over square root 2. And so I am maintaining shape consistency. My shape doesn't change, but my volume shrinks by 1 over square root 2 for this little tiny pixel of 3 space that lived in 8 dimensions as square root 2 length. Now it lives down low as 1 length. And that contraction from square root 2 length to 1 length on the volume is equivalent to a magnitude of curvature of a 3D volume into the 4th flat spatial dimension. So I call this a pixel of curvature equivalency. In addition to contraction being equal to curvature, so is twist. Now, when we sequentially project our 24-cell convex hulls to 3D using the camera orbit compounding method, we are, 1, creating 8D directed hypergraphs. So up in 8D with no projection, just 8D, it's a directed hypergraph. It can repeat, right? And 3D, we are creating, if we follow through with the projection, if we allow these, if we put film in these 3-dimensional cameras that are orbiting around the surface of a 7-sphere, right, around the 24-cell 10 compound. If we put 3D film in those cameras and we let them take pictures, now we're creating in our 3D rep a directed graph on a 20 group. By doing that, by doing the compounding, right, the orbiting camera with sequential photographs of parts of the Gosset polytope instead of the whole enchilada at one time, by picking those 24-cell or those D4 root lattice polytope subparts, we are introducing twist in the relationship between these sequential photographs. And twist has a different or second form of equivalency to curvature. So the fundamental mathematical thought then is a pixel or a quantum of a substance equal to transdimensional curvature. It is the transformation at the most reduced level. It's the transformation of these one-dimensional objects, the E8 unit root vectors, and their emergent objects. So when you observe something visually, you transform it, right? I mean, every time you observe anything, you transform it. And observation is supposedly integral, right? Integral to a lot of popular interpretations of quantum mechanics. So maybe think about curvature pixels of reality as transformations by observation. It's a transformation that is a baby, because the baby is always created by a mother and a father. And so the baby always has a representation of the mother and the father in it, plus new combinatoric information that's emergent that neither the mother nor the father had. So in this case of a metaphor, the mother is the pre-transformed object, the sort of primordial seed is this pre-transformed object. And then the father is this thing I introduce. And I give a relationship between the father and the mother, which is a hyperangle. So the father for me is a shape. And inside that shape in higher dimension, I can have points and edges. And so the angle of that shape relative to the angle of the transform object, which is the window, and in the direction it projects to some lower dimension, creates a relationship between it, the father, and it, the pre-transformed root polytope of D4 or E8 or whatever. So the baby is the relationship between the mother and father, i.e. the quasi-crystal. So feel free to switch up my metaphor by changing mother and father roles. So QGR babies are equivalent to letters equivalent to curvature that play a part in a language of letters of curvature that then play a part in a simple program made of units of curvature equivalency. So the paint that we are painting with in the code, which is the Fibonacci matching rules and their higher dimensional analogs, is curvature equivalency. The simple program is also playing off legal expressions of this code of 2 or more curvature values that have to be ranged in a tiling language. So because we are talking, we're taking a language theoretic axiom, right, about reality at its philosophy, okay? So when Einstein and Bohr were arguing about what quantum mechanics means, they were having philosophical discussions. They didn't really disagree on the math or the model. They disagreed on what the model meant, and that was a philosophical discussion. And so we're speaking about a philosophy here, which is the philosophy of what is physical, what is real, right? So it's a philosophy of physics. And many of you have PhDs in the philosophy of physics, the philosophy of that which is real. So in our case,
The volume actually shrunk by 1/2 to the third.
okay.
The lens.
Okay, thank you. So in our case, this ultimate letter, right, which is a thought that comes from the running of a simple program, which lives in thought, is a mathematical quantity, which is equivalent to curvature, to some quantity of curvature. So in our case, it is a regular tetrahedron that has been shrunken by some curvature equivalent value of something, and then twisted by another curvature equivalent value. So you've got these two things to deal with that seem to be mathematically factual. If the twist and the contraction can both be said to be equivalent to curvature, then they're there in our math. The foregroup is in some sense equivalent to a 3-simplex. Now, in some sense, a square is equal to a square lattice because the square contains the same parallel line classes. So give me a little latitude with the phrase in some sense. So a 3-simplex and a 4-group share the same 6 parallel line classes. So consider that wooden tetrahedron that you all subconsciously look at on the kitchen table every day. Now just copy and translate those 5 tetrahedra. No rotation. You will generate a right-handed 20 group without introducing any rotations or any new line classes. And that's because that is a right-handed tetrahedron 5 compound on the kitchen table. And so just copy and translate, slide outwards, tetrahedra, take the center one, slide it out to a point where you translate it, where at that orientation, one of its vertices becomes coincident with the centroid of the tetrahedron 5 compound, and then repeat that, copy and slide 3 times in the 3 remaining directions, then delete that first tetrahedron, repeat for the other 4, and now you've converted it to a 20 group right-handed, and you have introduced no additional line classes. So you can simplify the right and left 20 group to a compound of 10 regular tetrahedra with the exact same edge classes as a right-left 20 group. This object possesses curvature equivalency pixels in the form of this 1/√2 magnitude contraction and curvature equivalency in the form of twist value. So it's got those two, the 20 group has those 2 different curvature equivalencies encoded in it. So forget Gossett polytopes, forget 600 cells, just work with 24 cell 10 compounds in 8 dimensions and 24 cell 10 compounds in 4 dimensions and 4 group 10 compounds in 3 dimensions, and just see them each as an n plus minus m dimensional representation of the others. Now, warning, you have to go one step further than what I just said, because I said 24 cell 10 compounds. So in 4D, you have, I'm gonna get to that slide in a minute. So the step further is erase all those edges on the 24 cell 10 compounds and forget about 24 cells. And draw your edges differently and draw a 25th point at the center of the 24 cell. And then start drawing lines until you get a set of lines that will exactly project to either a right-handed or a left-handed 4 group. And then you can have a correlation in an object that is a 10 compound of something that has 10 convex hulls of 24 cells in 8 dimensions and 4D, but that the edges are drawn differently. So I'm not sure that we should use the term chiral 24 cell 5 compound. I'm not sure that we shouldn't, by the way, but the fact is that if you use those 10 orbit positions in my camera concept for construction of a compound, and you do that to take those 10 4D photos of the 10 24 cells in 8 dimensions, then what you're going to get is a compound of 10 distinct 24 cells in 4 dimensions, not 5. And they share vertices, that's for sure. But also in the 4 group, they share vertices. So if we're going to allow ourselves to call something in 3 dimensions the 4 group 10 compound, then we should call the one in 4 dimensions the 24 cell 10 compound, or we call the one in 3D the chiral 4 group 4 compound. So I don't care, but we should just be consistent with it. We talk about it later. So last part, and then we're going to do this in 1 meeting instead of 2. So hey, same color as Richard's shirt. All right, let us go shelling together. Randomly select a point in the E8 lattice. Now select 24 points living on a 7-sphere around that first point that are at a radius of √2 from that center point, so that you can define one of these 24 cells. Now next, so you've taken a Gossett polytope and you've selected only a 24 cell from it. Now go out to a radius of 2 times √2. and you will find a larger 24 cell of the same orientation as that first one. And then of course that would go on to infinity in integer multiples of square root 2. Now between these larger and larger 24 cells, we also have other 7 spheres with points living on them too. And let's call those other 7 spheres between those ones the interstitial spheres. And then we'll call those first spheres at each of those sizes of 24 cell, we can call those, the primary 7 spheres. So living as relationships between the points on both the primary and the interstitial 7 spheres, we have sets of unit length tetrahedra and unit length 24 cells, right? Depending on how you want to draw your edges, that are living at an infinity of radii in shells in 8 dimensions that are around the starting point we selected. But unlike the first series where we're getting bigger and bigger 24 cells that has a linear growth, these interstitial ones are aperiodic. There's an non-repeating pattern going on in there. So with the shell model in 8 dimension, these unit root integer multiple length 24 cell convex hulls are spaced on 7 sphere and 3 sphere rings at a constant density at a radii of 1, 2, 3 times square root 2. So it's periodic. But those interstitial 7 spheres and the shapes formed by the points on each are not periodic and are not constant in density. The density exponentially increases in an asymptotic manner. So one time Ray showed us a presentation where he took a periodic lattice, and when you take a periodic thing and you combine it with transcendental irrationality, which is a circle or any n sphere, you'll find this magical fact that as you do this shelling thing in a periodic lattice, you have these periodic shells, like a picket fence, like I'm trying to describe with the 24 cells of the different integers of square root 2. But then in between, you get this changing density where the density of the circumspheres increases rapidly, like a rapidly converging asymptote. And then you also have order, it's aperiodic order, but you don't have a repeating order of the species of shapes in the interstitial spaces in these ring systems. So it's a really neat way to kind of work with a periodic lattice and see this aperiodicity occur without any projection. And it's just by introduction of this important transcendental pi. So when we use the camera orbiting concept to push the periodic primary shells into a 3-dimensional rep in the CQC, then that which was the periodic subset that we called the primary shells, those primary shells get converted in the lower dimensional space, obviously, to a Fibonacci chain type of rule system where they're aperiodic. They get very close to one another in the lower dimensional rep as well. So as you look at the shelling in the lower dimensions, it's an asymptote where the distance between the radii of 2 sequential shells in the lower dimension gets very close, very fast. So this, so because of how fast this asymptote converges, it is going to help me to build up for you in your mind what I'm going to conclude with, which is that any large span of history in the universe is expressed on an incredibly thin but non-zero thickness of a gigantic 2-sphere, light years across. And if you were to take these tiny deltas in distance, like I'm going to get to the slide where I'm saying this, so let me put that on hold. So some section of this asymptote of Dirichlet coordinates, so remember in 3D, this system of shells is a Dirichlet integer system of shells. So as the asymptote rapidly converges, those are all based on ever diminishingly sized deltas that are Dirichlet integers between an nth and an mth shell, as well all of these radii from the center are also giant Dirichlet numbers. So anyway, you know what I call this thing, the action horizon, right? So let's say we have 10 to the 25 cycles of a cycle clock that is expressing an animation, right, of some little random walkie looking, quasi-particle on this action horizon idea. So those 10 to the 25 spheres, shells, that contain each set of centroid points, right, the centroid of a four-group. So cycle clock is a cycling of four groups in the 3D rep, it's four groups. And then as we're cycling it, we're translating it or making it move on a helical path, but all of that has to happen on the action horizon of these shells, these two spheres. And so we can place those, if we like, we can place those two sphere shells at the centroids of the four groups to represent it. So as an illustration, take the rotational center of the Penrose tiling and just start drawing circles centered on that point so that the perimeters of those circles intersect with other points. And you can presume that the edge length of your Penrose tiling is 1 meter. And then you can wonder, well, what is my nth and mth shells, circles that I'm drawing around the center, to where the delta between the nth and mth radii is less than the Planck distance if my starting edge length was 1 meter. So I don't know that answer. Instead of blurting it out, I want to make sure we convene on it and talk about it. Okay, so the point is that asymptotes and quasi-crystals rapidly approach their convergence. And the other object of convergence in the shell model is, and the object that it's trying to converge toward in the shell model in 3D is obviously an ideal two-sphere, right? A mathematically ideal two-sphere. So the shell model is a 2 plus 1D, not a 3 plus 1D model. The experience of it for us is definitely experientially 3 plus 1D. So a four-group on the action horizon could be described by a small number of two spheres that each contain some of the 12 plus 1 points of the four-group, right? So if you think about the orientation of a four-group on the shell model, you might guess, well, Klee, it's going to need at least 3 shells because I got to have 1 shell for its centroid probably. And then I'm going to guess I got 13 total points. Maybe I can pull it off in 3 shells, right? But it depends on what the orientation is in the first place of the four-group relative to this shelling system. So I don't know how many, but it's a small number probably, right? And so that small number of shells, assuming the four-group to be a Planckian distance, now we've got a little sequence of shells that describes the 13 points of the four-group, and it's a Planckian span, right, of radii. Right? They're really, really close because we're imagining the universe to be very big. We're imagining the four groups to be very small, Planckian. And so these, say, 3 shells that describe it are very, very close together relative to the radius of the universe. So these various ordered sets of two spheres with points on them define some pattern of interaction, for example, between 2 cycle clocks on an action horizon. I want to be careful not to blur you out or confuse you here or leave any man behind or woman behind. So I'm speaking of simple programs that operate cycle clocks on this action horizon, where the cycle clocks interact all according to something that plays off hit density flow patterns, the deltas and hit density patterns. And we're talking about this enormous index of weighted sets. And each one of these weighted sets is describing some universal evolution on this shell model. And by the way, any local place inside the shell model is also a shell model, right? Arbitrarily pick some point in the bulk, and there's shells around it that have basically the same form as the universal one. And so when I say that I need to cluster these three shells together, because in that case, I want to precisely describe the coordinates of a 4 group. I got 13 coordinates, and I need to describe all 13, and I need to do it with a series of shells that are really close together. And then that could animate to another position where the 4 group is at another position later, and I can start ordering these shells. Because the thing about inflation in a shell model is that's where your syntactical freedom is. I go to this shell, and I go to this radius, and I've laid down 17 shells, right? Now, as I lay down my 18th shell, I have syntactical freedom because I'm doing it based on omission, because it's an inflation principle. So I'm omitting shells in the phi-0 space that I'm omitting, and which ones I omit defines the shells that I've said are laid down. And so it's completely language theoretic at that point. You can lay down the order of shells if you're doing them one at a time in any way you want. Not in any way you want, but according, within the rules. So the action horizon, so this thing I'm having trouble explaining is that one of these little clusters of shells that defines the coordinates of one 4 group, right? And then you could go to another cluster, and then it defines the progression, right? The walk of that 4 group along one of these quasi-particle patterns. So that is not there. That is just something in this vast index. But they do kind of go together in little families. Like if I expect there to be a 4 group in some ordered set in my gigantic index, I want a set of coordinates, those 3 shells that will describe real coordinates of a real 4 group. And then how that evolves to the next 4 group, I have a lot of choices because the shell model possibility space keeps changing. Every shell selection comes with yet a novel new possibility space. So the distance and the exactness by which 2 sequential 4 groups can be placed together in these large sets, there's a lot of variability. But for one 4 group, if you want to say that's there, I've got it, okay, then that's 3 specific coordinates if it took 3 shells. This would be a good example of something where we have to circle up in the future later to make sure that we leave no man or woman behind in the comprehension, because I need you guys to comprehend all of this. So the action horizon concept is both simple, but it's also easy to get confused by if you're not careful, and if I'm not careful with the communication. So let us talk about it a bit more. The 2+1D action horizon is not something that we can observe as scientists if we have emerged as animals from the system, from the simulation. If we've emerged from the action horizon, we cannot observe it. So in this sense, the action horizon is pre-physical, similar to how in the holographic principle style of thinking, they would say that the 2-dimensional surface is not as physical as the bulk to which it is projected, right? So there's a similar idea like that here. But be careful not to get what I am saying or thinking confused with ideas like the holographic principle. It may be equally dissimilar as it is similar. For example, your notion of this 3+1 dimensional experience around you would be illusionary in some sense in my model, but since all that exists is thought in my program, then even your illusion in high EC is as real as the pre-physical math thoughts. And the pre-physical math thoughts are real. Why? Because they're thoughts. Because if it's thought, it's real. If it hasn't been thought of, it's not real. That's the ontology, and that's the new language, because prior to this, there was this idea of the word abstract and real or physical. This is abstract, this is physical, this is real, this is not. So in this paradigm, if it's thought, if it has been thought of, it's real. If it hasn't been thought of, it's not. So, and it is the physical 3+1 math of your reality because you think it into existence. You think the model, the experience, the whole storyline. This is the most important. These are one of the most important objectives of a conscious universe, is to create experiences like us where we can traffic in thought and transcend and grow and learn and relate to one another, right? So it's very, very real. So regarding the opportunity for confusion with the holographic principle, it's the bulk that I want to tell you to be aware of. So the bulk is the experiential model you have in your head about experiences here in the simulation, in my model. So in my toy model, the word bulk is your experience of a 3+1 reality. So in my shell model, the bulk contains the past. So it's a concept similar to universal time. So in my bulk, going backwards from the sort of big bang of the shell model, if you will, small radii sequences of shells would be basically deep past. In the holographic principle, the bulk is the world you experience, and they think of it metaphorically, at least, as a projection of the 2D boundary. So what is the +1 then in the shell model, if it's not time? Maybe we can call it universal time, but it is not the time of the cycle clocks. So it's not the time that you experience. So just be careful if you want to call this universal time, because you're subconsciously trained to think about time as that stuff you experience, that stuff of special relativity, right? This idea that time can change for, different relative movers, and your experience of time and all in physics, classic physics, but also special relativity. This is not that time, the increasing radii. So for me, I sometimes think that I'm conservative. And in this case, I suggest conservatism, and let's stay mathematical and call it exactly what it is in my toy model, which is radius. In other words, the +1 here is a series of increasing radii. And so if you want to play around with ideas of universal time, then I have to ask you, do you think that these shells are actually being added to the action horizon in some dynamic sense? Me personally, I don't have any reason to believe that they are being added. It's just a bunch of shells as far as I can see. It's a giant index of different orderings of shells.
Confused about where the 3 came from. If the +1 is going to the radius, because it sounds like you're saying you have 2D shells in a 3D space, but then we're claiming this is somehow a 4D space.
Yeah, I'm saying that your experience, I was trying to explain my experience is that I have in my EC the information of 3 spatial dimensions, and inside those spatial dimensions, from my vantage point, I see things changing. So I'll call that +1. And so it's real if I say the 3+1 is real, if I say that thought is real. So I have this real model, this real experience of a 3+1 reality. But I see myself and the rest of us moving, well, our consciousnesses are riding on this action horizon, and it is actually 2+1D. The +1 is our changing coordinate of our consciousness moving on it. I have a few more slides that will embellish it a bit. it's to bring your attention back to that question at the top. Do you think that these shells are being added to the action horizon in some dynamic sense? Because dynamic sense implies time. In other words, it was not added at this point in something like time, and then at this other point in something like time, it was added. And so we have distance here, radius for sure. So I am just saying, for me, at this point, I don't yet have any reason yet to believe that these shells are being added. It's just a bunch of shells and then weighted sets of a bunch of shells. So it's many shell sets, all with different weights. So
I think to be conservative, you are right. We could authorize ourselves to call this universal time only at the condition that we can prove it's not contradictory or not incompatible with special relativity. And until we prove this, we don't call this universal time.
I think it's worth discussion. I think that we could call it universal time. We could not call it universal time. I don't want to have a judge, and I don't want to have a, I don't think it's going to work to get all, 7 of us right now to fully flush it out and get everybody to buy in or not buy in. So let's.
I mean, I think radius is good because it's like very descriptive and it like can't be wrong, right?
Yeah. So I'm just saying, maybe we be conservative at least for the rest of this year on it. I mean, I've gone back and forth because I met with Richard and Fong and I said, okay, fine, we'll call it universal time. But I still have a trepidation in my gut. My wisdom tells me, if you're going to let them say universal time, if you're going to bless that term, then tell everybody to be careful. Just think, keep stepping back and thinking. So no one ordering is more real than any other ordering. They have different magnitudes of weight according to how the simple program gives them weights, but they're all equally unreal or real. So more abstractly, the ordered and weighted sets of increasing radii are a set of Dirichlet integer coordinates in 3 dimensions. So it is kind of like the 2 spheres are 2D, but they composite to form a 3D.
In fact, it's the square of the radii.
And integral octonion coordinates in 8D. So I'm saying, if I've got this shelling system in 8D, okay, that's an 8+1 world, or it's an 8-dimensional world because they're just shells in 8D. And then if I've got this set of shells in 3 dimension, they're just shells. There's no notion of me adding them. But if I were to decompose it in 8D, I'd say I've got 7 spheres that have 6-dimensional surfaces. And then I've got the idea of adding them. So that would be a 6+1 model in 8D for the shelling. 7. Oh, right. 8-dimensional. Yeah. Thank you. 7-dimensional surface of a 7 sphere. Okay. So then in 3D, I've got a 2-dimensional surface and then changing radii. So 7+1 in 8D, and it's a rep. And then I've got 2+1 in QSN, and it's a representation. Which one is more real than the other? I don't know. All I know is my experience gives me some kind of picture in my EC that I'm in like a 3+1 experience. So as an animal with emergent consciousness in this system, it is you paying attention through your consciousness that gives you the experience of riding through time. But it's not the experience of riding the action horizon. Your experience is more based upon the cycle clocks, right? And all of the change of interactions that the cycle clocks can create when they're not moving at relativistic speeds. So it is you paying attention through your consciousness that gives you the experience of riding through something like time. Maybe you can very creatively think about it as though your or that some kind of consciousness is riding the action horizon. So we have this set of shells, but it's also a set of shells in this vast index of weighted sets of shells. And something like consciousness, at least your consciousness, rides through that experience. And you never get a high resolution picture of what the shells are. You never measure anything, like even the duration of your measurements. Like your brain can't even measure things in any Planck moments inside of some really large number of Planck moments, right? And we can't measure spatial resolution to anything remote. So what we do is we ride through this giant index of weighted sets, this super abstract thing in the mind of a collective consciousness. And then we start modifying the weights in a very interactive, thank God we don't have to do all that work in our monkey brain, but somehow the interactive, giant, collective substrate can deal with that. So just because you are riding along some section of the action horizon here in 2021, that does not mean that other riders are not observing sections back in 2020 or up in 2022. It also doesn't mean you can't. You may be able to take your consciousness, even though you're a mere primate, and you may be able to put your consciousness somehow, some way, call it astral traveling, remote viewing, being like a ghost. You may be able to put your consciousness on other radii spans of the action horizon and see things at different times. So there is something absolute. There's a broken symmetry in this framework. And we introduced that broken symmetry well in the self-simulation hypothesis paper. And we talk about how simple things beget more complex things, which beget yet more complex things. And there's this directionality that we spelled out. And you can see this as the universe evolves from a quark gluon plasma to an early hydrogen universe to the first emission of heavy elements out of the first supernova, and on to the first biospheres, and it keeps going. And anyway, and we can see this in a microcosm with human society or life on Earth, right? When there was once supposedly just a single microorganism. And so there's that directionality. Now, when you're talking about a whole universal cosmology that's based on the SSH paradigm, then there is an absolute hierarchy evolution. Ours is an evolutionary model in a deep generalized sense. It's hierarchical, it's evolutionary, and it's language theoretic, where we co-opt the concept from language theory of words, sentences, paragraphs, and kind of emergent meaning. And then there's a second broken symmetry, which is the radial increase. So there's a singularity at the center where the radius cannot exceed 0. But in the other direction, as it goes out, then so far, right, we don't have any big reason yet, staying humble in the toy model state, we don't have any big reason to say that there's some cutoff. So you see, that's a broken symmetry, because in the one direction, you get to a singularity, but in the opposite direction of radius increase, you don't. So that's why I agree with Fong that it does model something like the universal evolution, where the universe at the Big Bang had one level of complexity, and today it has a different level. Complexity is changing. Complex systems complexity seems to change over time. So, and why can't some consciousness mix things up instead of a consciousness, like I saw my own son do it in moving around in time with his consciousness in a way that he proved it to me. But why can't some consciousness someday mix it up and network in their non-physical emergent minds various radii spans of action horizon to create a strange form of what we might call trans-temporal thought, right? If a consciousness, even in animal form, were able to plug into some non-local substrate of reality? Or what if a consciousness could exist that's not bound to be made of atoms? Could a consciousness exist in other networks that exist? And could those consciousnesses have a form of thought that is spread like a network in time or space? I don't know, but if we think about it with respect to this radial growth, we would call it transradial thought, because I'm saying that there's this action horizon around the end of August, 2021, and here we are, right, writing it together. And then there would be this other one where I think, well, what if I could put part of my consciousness back in other places in time and network that all together and think trans-temporally? But I guess you could call it transradial thought as well, if you're thinking about different spans of an action horizon being at different points in this notion of evolution of like universal time from the Big Bang kind of concept. So, okay, so let's stay conservative and just see this mathematically as weighted sets of shells that increase in radius. We don't know what consciousness is. We do know it has something to do with producing the experience of motion and abstract ideas like change and time, and that it also has something to do with quantum mechanics, at least in some popular interpretations. So pushing a little more to ensure that you don't get mixed up with the holographic principles idea of a bulk, let me ask you this. How many directions relative to the unknowable center of the shell model and the surfaces of the two spheres can a cycle clock quasi-particle move in, right? So you got the center of it all, and you got a straight line going out to some point on the radius of the action horizon. So how many directions can some quasi-particle evolving on the action horizon move in relative to that line?
That's exactly my question. Like if you have a helix moving on the center this way, right? So that corresponds to, like the time axis, and that seems to make sense for me. But what if the helix is moving like this, along the horizon?
Mm-hmm. It can. So the answer is, and it's not something I prepared diagrams or met with Fong or Richard or anybody to try to get it more clear. It is like homework. Think of it like that. I really want to get everybody to help each other understand all of the core elements in this presentation. So it can move in nearly an infinite number of directions relative to that direction that I described as a line going from the center to some surface of an action horizon. It can move backwards relative to that unknowable direction, sideways, or any direction that you could physically measure with your limited resolution of measurement. A near
independent direction, it can move in any.
It can virtually move, like it's a Planckian thing. So it can move for our purposes in pretty much any smooth direction, but technically, yeah, technically it would be some little discretization there. Again, asymptotes based on projective geometry of the form that we use, they really do approach their convergences with violently fast rapidity, I meant. And the particles on the action horizon, and now we're like just a couple minutes away from the last slide. So these are built up to the last slide. So the particles on the action horizon for the last 1 million years, for example, would be contained in a non-zero thickness of an apple skin around a two-sphere that is exponentially thinner than the Planck length. Now remember, in the experience that you roughly think of as 1 second of non-relativistic speed existence, there are approximately 10 to the 44 shells that would be laid down, right? and then a big index of different weights of different sets of 10 to the 44 shells. So when you're talking about a universe that's 13.7, billion light years, then you've of course so far approached the convergence point of the asymptote in terms of the distance by which two sequential shells can be as you draw two spheres around them, that you could literally take the last 1 million years of all evolution on the growing action horizon, and that itself, that million years, could be contained in an incredibly thin apple skin around this cosmological sized two sphere. In this sense, then, the last 1 million years of evolution of Earth in this 3+1D experience of ours is encoded on virtually a zero thickness surface of a two sphere with a radius of more than a dozen light years. Now, these are the two spheres at the centroids of.
Why more than a dozen light years for the radius?
Oh, just I didn't want to look it up. There's some, when you deal with redshift, there's different models of what the radius of the universe is. Some people would say it's a diameter of 34 billion light years. Others would take it without redshift. So I didn't want to get into that, into actually looking up a real number, because then there's competing models. So I took more, I think I said more than a dozen. Yeah, I just tried to say more than a dozen.
More than 12,
More than 12, yeah.
as opposed to 34 billion.
Oh, I'm sorry. I left, it's a typo. More than 12 billion light years. Sorry. Good catch. Good catch. All right. So now these are the two spheres at the centroids these are the two spheres right at the centroids of the four groups in the cycle clocks. That is, if you're not trying to capture all 13 points of a four group where you need them to stay Planck distance apart, roughly speaking, if you're assuming the edge length to be Planck length of a four group, okay, then, but if you were to have taken just the centroids, then as you go from shell to shell in this math, you'll find that the shells get exponentially close together, smaller than the edge length of a tetrahedron. These are the shells that are close together. So the four groups can be further apart, but the actual two shells, right, but that would circumscribe two of these giant things would be very close together. And what I just said in my statement about less than the Planck length was if we're taking our two spheres and putting them at the centroids of the four groups. But if we use the small set of two spheres that I estimated as 3, that contain all 13 of the vertices of a four group, then we can recognize the unit length of the CQC tetrahedra as our presumed game Planck length. And the shell and the sequential distances between the shells would not go down exponentially less than the Planck length, but it would still be Planckian.
So for your previous slide, you mentioned 3+1 in relation to a shell model and talking about how, so before you were saying that the 2+1D shell model should not be related to any 3+1 reality, and then.
No, he meant it's a 3+1 experience. He's articulated that
Yeah.
our experience of it has this 3+1 nature to it, but he's not saying there's actually a 3+1 dimensions in the physical model.
But
or in the geometric model.
yeah, but David,
So I
but
must have misinterpreted what you said originally. So I should be trying to connect this 2+1D shell model to something that leads to a 3+1D experience.
well, see that model on the table by Richard, that's a 3-dimensional object. It's not 4-dimensional. We don't have a +1. But we can decompose it into a set of 6 different two spheres. And so we can say that as we look at the radius increase of those 6 two spheres, we'll call that the +1. And then we'll say that each of those elements, those two spheres, is 2D.
I understand all that. That's just like not really, I can't tell if we're trying to connect this 2+1D model to a 3+1D experience It's like a yes or no question.
Yeah,
Okay.
we are. But what I was trying to explain right now is that it really is 3D because a two-sphere requires 3 spatial dimensions to even exist. So I want
So
to,
the bulk is
That's
actually
the
a
2
collection
plus
of
1. When you
balls.
say 2 plus 1, that's 3. There's no 3 plus 1.
right, and right, I don't have a 3 plus 1, I just have a bunch of shells and they can live in 3 dimensions. They don't need a 4th dimension to have increasing radius.
Right, and that's the 2 plus 1 you talk about.
Yeah, whereas my experience is definitely 3 plus 1. So
I mean, you just go to the bulk and then you say that I have a memory of everything in the past. So at this moment, I have a ball that's bigger than the ball at the previous moment. So actually the 3 plus 1D is in the bulk and it's a sequence of increasing balls.
maybe
And then you have 3D
yeah.
space and then you have a 4th dimension of the increase.
But it's
I-
really what's inside the bulk is really not 3 plus 1.
Right, so you have a collection of balls, right? Of increasing size, you have copies for each slice, each time slice.
A collection of increasing sphere.
And in each ball is completely independent of the next.
I think it's 3 plus 1D. I'm gonna maybe
Sure.
correct
But
myself.
That may be the dimension missing,
Right.
depending if the ball are the same or if the ball are different.
I think it's 3 plus 1. I think I would correct myself. And the reason is because I'm trying to say that nothing physical exists over sufficiently large frames. Like let's say you need 5 frames to define a particle. Okay, if that's the case, then it's a 3-dimensional volume that it's 1, 2, 3, 4. It's several shells of different radius. It's an apple. Is an apple skin 2-dimensional? No, it's 3-dimensional. There's a thickness of like less than a millimeter. And so each of my sections of the action horizon that defines something physical is a non-zero thickness object. And then my model is as that non-zero thickness object changes, change, that's a random walk for me of a quasi-particle. So maybe it is better to say 3 plus 1, but I'm just saying we can decompose and talk clear and say you can get to that 3 plus 1 picture with 2-dimensional shells that contain ideal 2-dimensional spheres that two spheres that contain points on them at a really rudimentary level of breaking it down. Yeah, thanks for pushing me a little further on that, David, because I think that the action horizon is non-zero thickness. So, but it's built of these little mathy things that can be seen as points on 2 spheres.
So you're saying that action horizon has certain thickness, probably like Planck lens, let's say, but within the Planck lens there are many shells. So that's why we're having a 3-dimensional experience there.
Yeah. Okay, so
We can imagine from this thickness an action horizon as a hologram, and then in this case you can have the experience of the 3D inside of the hologram.
that is exactly what I was saying. Don't think that. That was my several slides saying.
I
don't-
heard this, but otherwise,
So
how you
we
can
move
have
in
this
3
3D
arbitrary
experience.
3 directions. We can move in 3 dimensions if we're particle. I think there's still it's not clear if particles have to be confined to action horizons, because you said that particles can move in any direction, yet you said that action horizons expand spherically, and then you refer to particles on an action horizon, but it wasn't clear if you were restricting to only the particles that live on the action horizon, or if you were constraining particles to.
So there's an action
only
horizon.
five.
Sure, sorry. There can be an action horizon around any point in the bulk. So around any point in the bulk, you can just think it almost without even calculating. You just place spheres that contain points, and you'll notice it has the same basic structure and math and looks the same as this universal one. It may not have the ideal symmetry of the universal one, but by the way, guys, the universal one doesn't have symmetry, because the code theoretic ability to delete shells and to arbitrarily pick your shells means that syntactical freedom is going to break your beautiful H three symmetry from the get-go.
So it's like this, right? There's a big thing, but then each
Yeah.
individual particle
Yeah.
has its own.
Yeah.
thing like that.
Yeah,
But we do want something absolute because you said there is an absoluteness.
there is this cosmology model that lives in my toy model, which is reminiscent a little bit of the Big Bang. And it is also a little bit reminiscent of certain, at least metaphorical things in the holographic principle. Because whether it's one of the, Fong drew a picture of a whole bunch of rings, and then she picked some point in the middle and started drawing rings around that to ask me if that's what I meant. And I said, yes, that's exactly what I mean. You can start drawing two spheres around any point in the bulk, and you'll see that you have an action horizon. So it's like all these action horizons interacting.
So can we think of the bulk as like a discrete ball? Like it's like a volume kind of with discrete points,
Yeah,
and then there's,
yeah.
so it's like there's shells, and then there's this on the boundary and a ball on the bulk.
Fun, we can't even see that. We got to figure out a new way to place our markers flat, because
Yeah, it's just like this black one, that's kind of like some absolute or universal, whatever. But each particle has its own thing going on there.
right.
So maybe it's somewhat relative.
Right.
Unless you choose one to be the absolute.
I think that I can even see observer requirements in Einstein's thinking, in both, in special relativity. Certainly, he likes to say, well, there's nothing absolute. It's just your experience of time can only be compared to some other clocks and other movers. And so it's a very personal experience kind of philosophy that comes out of special relativity for me. And then by looking at a Copenhagen type of interpretation,
It's
it's,
not personal, it's frame.
yeah.
Millions of people in the same frame are gonna have the same time.
Yeah, but they all have minutely different times that you can't measure the difference. But
No, if they're in the same frame, actually.
if they were, but realistically, we're all moving
Right,
it
so the-
minutely
The
different.
point is, it has nothing to do with the person, it has only to do with the frame.
Okay. But it seems that, yeah, it just goes down a rabbit hole. I think with Einstein, you still have this, Einstein was definitely a materialist, okay? So he wasn't an idealist with this kind of philosophy, but he would, yeah, so there's a difference, but still in the Einsteinian view, to try to make it, to find connections with my view, nobody knows what their inertial frame of reference is. In Einstein's view, it's because there is no absolute inertial frame of reference. All we can know is what we can do as scientists or observers to experiment. And so this word observer comes up all the time. It's integral to the special relativistic view. And in a very different way, completely different way, the observer has a very integral view in Bohr's way of understanding what quantum mechanics means. So I'm saying, in my view as well, both where you're at, like David said, it's like relative, David was talking about what Fong drew, like some person evolving on a action horizon in the bulk, right? But then we have this one special bulk, we have this one special action horizon. That's the cosmological one that would be it someday our toy model of a Big Bang kind of universal evolution where we have a broken symmetry. In other words, the universe is bigger today than it was a second after the Big Bang. So that is a broken symmetry. The universe is also a more complex system today than it was in the past. So remember, the physical reality in this story is a very large set of ordered sets of different shells. So it's many sets of shells, many action horizons. The set of weighted sets that is deterministic and generated by the simple program. So a simple program generates the large index of sets, each with different weights. The different foregroups between two or more of the weighted sets can be exceedingly close exponentially smaller than the Planck length. But the points on one foregroup, right, define the 3 shells defining one foregroup, they cannot be arbitrarily close or exponentially smaller than the Planck length. But the distance between two foregroups could be very close.
Well, I guess
Yeah, that is strange.
the radii and the shells going through 2 foregroups can be.
Right, the 2 shells can be very, very close, but the 2 foregroups, they'll be translated on one shell relative to the other. But if you're operating at a higher inflation number, right, if you're operating at, say, 5 to the 18 on your inflations, then of course these bigger foregroups could get closer together, because now you've got a lot more degrees of freedom, because that's the magic of changing your possibility space and changing per shell that you add. You make new syntactically free choices that you wouldn't have if you did a global projection of the whole thing at one time.
Maybe the blank scale need to be set in the asymptotic,
Yeah,
because it would be a sub-Planck scale model.
yeah,
Or you could have the action horizon shell thickness maybe be the Planck scale, so you have like multiple frames, so it's
Yeah.
like smaller.
right. Okay, so the takeaway here is that long durations of universal evolution are encoded in a purely probability-based sense on the surface of a two-sphere that is not perfectly smooth, but where the hills and valleys at this size of the universe would be like 10 to the 60 times smaller than the radius of the two spheres today. Like, you know how an orange at the David to Klee distance looks flat, I get closer, I see these cool little, like a golf ball, little dimples. This universal thing, the dimples, the hills and valleys are exponentially smaller than the radius of this two sphere. So it's practically a two sphere. And all of that last million years is encoded practically on a two sphere with a little bit of a corrugated surface. The two sphere has Dirichlet corrugated encoding on the surface that is not just simple Dirichlet, it is Dirichlet as modified by our simple program. So it's orderly because it's guided by the simple program. It's statistical because it's a giant index of these different dimpled surfaces. So it's not just one dimpled surface. So there's a deep connection in this system to the 7+1 aspects of the integral octonions. The 7+1 takes the form of the form of the 3D slices through the representative polytope of the Elser-Sloan quasi-crystal, the palindrome. So the representative polytope of a algebraic root lattice is that polytope that contains all the root directions, the relative local angles, all your good stuff of your root lattice. So if you say, well, what's the analog of a root lattice polytope in a quasi-crystal? Okay, so for the Elser-Sloan, that representative polytope would clearly be the Elser and Sloan, the 600 cell. So if you take the slices through the 600 cell, the three-dimensional slices, you see this palindrome, right? The 7+1 palindrome. And the 8th value, or the 7+1 is in the E8 3D, is in the 600 cell 3D slices. But then if you project the 600 cell to 3D, you lose the 8th layer because it gets projected onto the surface of the 7th layer. That is that asymptote. It converged at 7. So in other words, if you look at this projection of a 600 cell here, then you can see that the tetrahedra on the inner layer have not been compressed. They don't have a curvature equivalency that's very big because they're barely compressed. And then if you go to the next layer of tetrahedra, the second layer, it's further compressed, right? And if you go to the third layer, it's even further compressed. Okay, so the point is that you have these different layers that used to be the Gaussian polytope, and then that got crushed down to a pair of 600 cells, right? A Russian doll of two 600 cells. And then you take one of those 600 cells, or you take part of the half of the Gaussian polytope, and you can project it to this plastic zone model. And because the compression is an equivalency to curvature, you can see that the inner 20 tetrahedra have a subtle curvature equivalency. The second layer has a less subtle. And then as you go out to the 8th layer, so if you get to the 7th layer, you have very flat pancake looking tetrahedra when you project the 600 cell to R3. And then that 8th layer, which exists in the 600 cell, it reaches its convergence fully. That is the height of that tetrahedra, right along this direction from the centroid out. The height gets flatter and flatter and flatter as you go out, and at the 8th layer, it gets down to 0. That is a tetrahedron in 4D flattens to a regular triangle in 3D, and it lays on the surface of the 7th layer. So this flat pancake tetrahedra of layer 7 have pasted on top of each of those triangular facets of those tetrahedra, flattish tetrahedra, an 8th one. And so this 7+1 structure that relates to 8 dimensions is there, but you only get to use mathematically the 7 values that you'll see. So we have a 7 unit palindrome in 3D. So when you go to any H symmetric 3D quasi-crystal, you'll find 7 all over it, but it ultimately comes from the 8, which you'll see easily in 8 dimensions, and you'll see it in 4D in the Elser-Sloan, and you see it represented as 7 in 3D. So the 8ness and the related 7ness, right, because of that flattening of the 8th layer, which depends on the dimensionality of the rep. So it's 8 in 8D and 4D, and then it's 7 in 3D. So this must be represented, this must be fundamental to the simple program and the emergent energy landscape, because how could it not be? This 7 repeats at every power of phi. Those 7 basic numbers exist an infinite number of times at each power of the golden ratio in these H3 symmetric quasi-crystals. And since the CQC is this type of quasi-crystal that has that exact palindrome all over it, somehow the complexity of the richness of our simple program, our energy landscapes, and everything is carrying with it these 8 values of the 7+1 integral octonions, the 8 values of the 8 fundamental directions, right, to describe R8. Like that's a deep part, the number 8 or maybe 7 is a deep part of our code. And then this idea, for example, guess how many letters you get if you take the E8 lattice and you project it to an H3 projection in 3D. You get the identical square root 2 unit root vectors in E8. They all get compressed down. You could have 100 billion of them, and all 100 billion must exist only in the set of 7 Dirichlet values that exist in the E8 to 3D H3 symmetric quasi-crystal. So in the QSN, we refuse to let the edges contract any more than they already contracted when they would have gone from 8D to 4D. That's the contraction value of that 1 over square root 2 factor, right? And so because we won't let them go to the 7 Dirichlet values that they would have gone to if we sent those unit roots all the way from 8D directly down to 3D, then we force remember, each of those compressions of those 7 Dirichlet integers of those unit roots, those are each equivalent to a different magnitude of curvature, depending on what the angle of that little straight line was in 8D relative to the R3 projective space.
We've talked a little bit about that before. Yeah, I think we need to revisit that.
Okay.
Question of curvature, whether it's really equivalent. To
Okay, let's make sure we do that because that's important. So I do still believe, until we can see that I'm wrong, or until I can see that I'm wrong, that there's an equivalency, or maybe there's a better word than equivalency, but there's a mapping between curvature, twist, and contraction. And so if I've got these 7 contraction letters that have a curvature mapping of the unit roots down low, then I got a 7-letter alphabet. But if I don't let them contract, as we do with the twist isomorphism, I still have my 7. It's all over the place. Ray showed us, like you can take the centroids of every 20 group in the QSN and you can start drawing lines between them, and voila, you will see the exact same 7 Dirichlet integers that you see if you were to project E8 directly to 3D. So I'm just saying that a deep aspect of our code, a deep aspect of our simple program, a deep aspect of the aperiodic energy landscapes and the mathematics that we use must have this 7 values in it. How could it not? Because those 7 values in some deep way are related to the 7+1 integral octonions, to the 8 fundamental directions of 8 space, and probably a few other, sophisticated algebraic type concepts.